elimination reactions of alkyl halides. So here we can see elimination reaction mechanism due to rearrangement of carbocation. Okay. So elimination reactions. These are also called as dehydrohalogenation reactions. One hydrogen atom and one halogen atom, they are removed from alkyl halide by using dehydrohalogenating agent. So here alcoholic potassium hydroxide is dehydrohalogenating agent. Okay. So it removes both hydrogen and halogen which are present on the adjacent carbon atoms. For example, if we take a simple reaction, ethyl chloride undergoes dehydrohalogenation in presence of alcoholic potassium hydroxide. Okay. So here with the removal of one hydrogen and one halogen from the adjacent carbon atoms, we get unsaturated compound which is called ethene. Okay. Along with ethene we get potassium chloride and H2. So elimination reactions, these are in two types. Okay. Elimination reactions are two types. Elimination unimolecular reactions indicated with E1 and elimination bimolecular reactions which is indicated with the E2. Okay. So first coming to elimination unimolecular reactions. Elimination unimolecular reactions. So in elimination unimolecular reaction, rate of the reaction that depends upon concentration of only alkyl halide. Okay. Concentration of alkyl halide only. So one reactant species. Okay. So that's why this is called elimination unimolecular reaction. Okay. So rate directly depends upon the concentration of alkyl halide. And elimination unimolecular reactions generally takes place in two steps. So two-step mechanism is there. In first step, alkyl halide forms carbocation. Okay. So by losing halide ion. And in second step, carbocation loses hydride ion. This is also called as hydride shift. Okay. And we get further final product which is unsaturated compound. Okay. So in elimination unimolecular reactions, tertiary and secondary alkyl halides are involved more favorably than the primary alkyl halides. Okay. So tertiary and secondary alkyl halides, these are the more favorable for elimination unimolecular reactions for the mechanism. So it takes place through the formation of carbocation. So during elimination mechanism, this carbocation undergoes rearrangement. Okay. So due to rearrangement we get different products. Okay. So here for example, rearrangement of carbocation and elimination mechanism, we see rearrangement of carbocation. And here we take a secondary alkyl halide. This is tertiary alkyl halide. Okay. So this general example is tertiary butyl chloride. Okay. But here in the rearrangement of carbocation, a secondary alkyl halide is there, which is 2-bromo 3-methyl butane. 2-bromo 3-methyl butane. Okay, and it undergoes elimination reaction. In presence of alcoholic potassium hydroxide, this is also called as dehydrohalogenating agent. Okay, so here we get different products. Out of this, 2-methyl-butadiene, this is major product. 2-methyl-butadiene. Along with 2-methyl-butadiene, we also get 3-methyl-but-1-ene and 2-methyl-but-1-ene. Okay, so these are the minor products. Okay, so formation of these products through rearrangement of carbocation in elimination mechanism. Okay, so let us see that mechanism where carbocation undergoes rearrangement and ring expansion. Okay, for the formation of different products, where one is major product which is formed from more stable carbocation and remaining two are minor products. Okay. Okay. Here coming to mechanism. So this is secondary alkyl halide. 2-bromo-3-methyl-butane. Okay. So here first it loses halide ion. So with the loss of halide ion we get carbocation here. This is carbocation. So with the removal of hydride ion, here we get a product which is called 3-methyl-but-1-ene. So this is one of the minor product. 3-methyl-but-1-ene. Okay. Then carbocation which is formed due to the removal of bromide ion. Here it undergoes shifting. That is called alpha hydride shift. Okay. So this is cation. This carbon is cation. Okay. So hydrogen present at alpha position to this. It shifts towards the positive charge. Okay. So due to this we get a tertiary carbocation. This is secondary carbocation. Carbon linked with the two other carbon atoms. Due to the shifting of hydride means H minus. Okay. Towards the positive charge. And positive charge that acquired by this carbon. And this is the tertiary carbon. So you know about tertiary carbon. So tertiary carbon is carbon which is surrounded by 3 carbon atoms. Okay. So 3 alkyl groups are surrounded a carbon atom, that is tertiary carbon. So here we get tertiary carbocation which is more stable carbocation. So from tertiary carbocation, here we get two products. One is minor product. Okay. So this is 2-methyl-but-1-ene. Okay. Then major product which is 2-methyl-but-2-ene. Okay. So this is the mechanism which takes place in unimolecular elimination reactions with carbocation rearrangement. Okay.